The astronomical object of June 2025 is the center of the Milky Way, Sagittarius A star. Welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door.
Boring astronomy.
I'm Alessandro. I have been in astronomy for the past 20 years, and I'm here trying to share with you some of the things that I've learned along the way. It is June in the northern hemisphere, summer is starting, and in the southern hemisphere, winter is starting. And you probably know that people born in December are born under the sign of Sagittarius. How does this fit into this kind of video? Astrological signs were related to the position of the Sun with respect to a series of constellations. People who like astrology, it actually means that in December the Sun is in Sagittarius. Since June is exactly 6 months away from December, this means that the Sun is opposite to Sagittarius, and this means the Sagittarius is beautifully observable in the middle of the night during this month. I just find it like a very easy way to remember this. This is the sky above Cork, Ireland, which is the place where the European Astronomical Society meeting is going to happen. And at night you can easily identify a series of constellations like Ursa Major. You can see Cygnus, you can see Perseus, Cassiopeia, and obviously you can see the plane of the Milky Way. So if I turn around, so I come here towards, and I look towards south, I can see Sagittarius coming up, and doesn't really pop up very well. This actually suggests us that Sagittarius is best observed from more southern locations. What does our friend Simbad tells us about Sagittarius A star? It says that it's an X-ray source. This specific one is located at 17 hours 45 minutes, observable at this time of the year, and is at minus 29 degrees. As we just noticed with Stellarium, you observe it best from the southern hemisphere, and actually is one of the reasons why the European Southern Observatory has its observatories in the southern hemisphere, because one of the main goals was to look towards the center of the Milky Way. So if we now go to ESA sky, we can see what is in this area. This is an image from Pan-STARRS, and it's only a few arc minutes squared, and it has a lot of stars. Let's see what other wavelengths tell us. And you can see this is Chandra in X-ray, and you can see that there is quite a lot of interesting X-ray emission here, and we may or may not dig into the X-ray emission coming from the center of the Milky Way. This is near infrared. It's 2 mass. Is perhaps not the best near infrared image ever, but keep this in mind because we're going to speak about near infrared for this specific field a lot later. And then as we move towards redder wavelengths, the resolution that we get gets worse and worse, and we start losing. Sagittarius A star, if I'm not mistaken, was discovered by Fritz Zwicky, and it was one of the first radio sources ever discovered. It emits a lot in radio, it emits a lot in X, and it has a lot of stars in optical. As you could see from the Stellarium image, that is a direction where you have a lot of stars, and this is sort of obvious, right? So if you are on this place, the center of the Milky Way is here. If you look perpendicular, or if you look towards outside, you have less stars than if you look towards the center. Plus, here you have higher density anyway, so there is a lot of stars there. And it's a place which has a lot of dust, a lot of gas, and a lot of stars. So So it's a very, very, very rich place to look. But it was during the 1980s and the 1990s where we started to have the technology to look towards the galactic center and see what was going on there. This is one of my favorite videos of all time, and is from the University of California group, which built an adaptive optics instrument that was installed on Keck to do this observation. You can see this specific star that they emphasize, which is called S0-2, and it was the first star that we managed to see making a full orbit around something. And you can see that this star is making a full orbit and there's nothing in the center. At the end of the day, this is very much like the Earth going around the Sun. In the case of the solar system, it's easy. We see a star, we see a planet, and we can say that the planet is orbiting the star. But in this case, S0-2 is orbiting nothing. It turns out that there were two groups, one from the US and one from Europe, both developing adaptive optics instruments, which were installed one on Keck and another one first on the ESO New Technology Telescope in La Silla, and then eventually on the VLT. And they made these kind of videos and to see this star making an orbit around. And this is the ESO press release explaining the discovery. And by studying the orbit of this specific star, and in practice you can also do it with all the other stars orbiting Sagittarius A star, you can determine the mass of this central object that is not seen. And this central object which is not seen has millions of solar masses. You have an object that you cannot see and it has millions of solar masses. In astrophysics, the only object with this kind of characteristics is a supermassive black hole. This discovery was so important that in 2020, Rainer Genzel and Andrea Ghez shared the Nobel Prize for Physics for the discovery of a supermassive compact object at the center of our galaxy. The other half of the prize went to Roger Penrose for the discovery that black hole formation is a robust prediction of the general theory of relativity. General relativity was published by Einstein in 1915. It was only 2 years after that Schwarzschild predicted, on the basis of general relativity, the existence of these supercompact objects which would be so compact that not even the light could escape from them. For many, many years, they were considered a mathematical exercise. It was only during the 60s and the 70s, with the discovery of quasars, that the idea of this kind of supermassive compact objects started to be taken more seriously. The observation of Genzel and Ghez clearly demonstrates that this kind of object exists, and there is no question about it. The galactic center has been observed by now at infrared wavelengths for 3 decades and is going to keep being observed. It has been so far a very, very interesting piece of information, and I'm sure that for the next 20 years it's going to give us more and more interesting things to think about. But this is not the whole story. We have already spoken about the Event Horizon Telescope in this channel, and the Event Horizon Telescope, among others, has observed the supermassive black hole at the center of the Milky Way. And this is the image reconstructed from the Event Horizon Telescope. And you can see that it's not perfectly symmetrical, you can see the shadow at the center, and you can use this image to obtain information about the black hole and its surroundings. The study of the black hole at the center of the Milky Way has been a main driver for a series of technological evolutions, like adaptive optics on one hand and very large baseline interferometry in radio, And we have been using this a lot over the last decades. Currently, some of the most interesting developments in optical interferometry with gravity and gravity plus are pushed exactly because of this science case. This object is a very specific science case, but it provides a framework that can then be extended. It provides an idea that then you can use for other galaxies. And by now we are convinced that at the center of every galaxy there is a black hole. So I hope that next time you're going to go out and look at the center of the Milky Way, you're going to see a lot of stars, and then you're going to think that in the midst of all those stars there is a huge beast that your eyes cannot see because physics prevents you from doing it. I hope this was an interesting trip towards the center of our Milky Way, and I'll see you next time. Talk to you soon. Ciao.